Hello everybody, good evening. Welcome to the week 8 interactive session. First I'll go over the summary of this week's course. So this week actually this week sir has covered a lot of new things, new and non-trivial things. So I will go over sir's PDF itself because there are lots of new things. Okay, so the first one was exception handling in C. I mean error handling in C. So in C, the language itself does not have a mechanism to handle errors. So programmers have to work around it. Uh, there are some industry practices on how to handle errors in C. One of the most common ways is to use this mechanism where we where the functions return a int value. The functions return a int value and to indicate whether the operation has been successful or not, and inside the function if there is any error or exception, then the value of the return type is set to something else like -1, and if the function works perfectly then the return type is set to 0. And now in the main body of the function we call the function and then we check whether the returned value is 0 or not. If it is 0, uh, then the function has returned successfully, and if it is non-zero then there is some error. This mechanism is very widely used. I have seen it in several libraries. Okay, not only in C++ also. uh, but then for to use this way, one of the sacrifices that has to be made is that the function cannot return the result. So suppose we have a add function. Suppose we have a add function that takes two numbers a, b, and it is supposed to return the addition value. But in this new format, what we do is we pass a, b, and then we pass a pointer to the output value, and the function returns the whether the operation has gone successfully or not. So it returns a return value or error code, and then we check whether it has worked successfully or not. So this is one of the ways. Now there are many other ways like global variables and abnormal termination, conditional assertion, non-local goto, and signals. So the global variable one, which is handled by the error node library. So what happens is that there is a global variable in the C program, and if there is an exception or a error in the code, the that variable is set to some value which can be used to understand that there has been an error. Next, we have the abnormal termination header. This is the abnormal termination header is used to terminate the program at some other point other than the main function. So as you know that in all C and C++ programs we have a main function where we write the main logic of the code, and when the main function ends the program exists. But using this stdlib.h. Stdlib.h has many other functions also. Okay, like memory allocation. But one of the functions is exit, another function is terminate, and there is another function abort. So these functions are used to exit from the code before the end of the main function has been reached. The next one is the assert header. The assert header is used to it is used mainly in debugging. It is not used in production code or the release build of the code. So the assertion. So if anybody of you have done Python, you will know that there also we have a assert statement. So this one is similar to that. So in the while debugging or while writing the code, we can write assert and then we can write some condition, and the program will check whether the condition is true or not. If the condition is true, then the program will continue. If there is a problem, then the program will exit from here. It will throw an error and it will exit. So this is mainly used to make sure that there is no hidden error or there is no hidden bug which goes unnoticed. Like let's say that there is an array whose size is supposed to be 3. So there is an array which is supposed to contain 3 elements, but actually it contains 2 elements. Okay, now when we are writing the code, somehow that error has got missed. Okay, and when we have tested it also, maybe that line was not being used or maybe some other thing was happening and the error is hidden. So the array actually contains less than 3 elements, but we don't know that. Okay, so later on when we release it and when somebody else is using the code, it will cause problems to them. So it is a good practice that when we write the code, we assert that something has to be true or not. So these kinds of hidden errors can be avoided. So since the assert function is used only in the debug builds, there is a macro that we have to set to tell the compiler that this is a debug build. When the macro is not set, then all the assertion statements are removed from the program, and these statements do not have any effect in the release build. Next we have the non-local goto, which is provided by the setjump.h header file. So this is very similar to the try catch statements which are used in C++. So when we are going through a function, if there is a problem, non-local goto can help us to jump to some other part of the program which can handle the error. So this is similar to the try catch statements. Next we have the signals, which is provided by the signal.h library. This is mainly related to the OS. Now the OS can send various kinds of signals to the running program. Like it can send that uh, if you use Linux operating system, then you know that CTRL plus C is used to terminate a program. So when a user press CTRL plus C, a terminate signal is sent to the running program. Now, ordinarily, when a terminate signal is sent to a running program, the program terminates. Okay, but we can use the signal.h library to override that behavior. We can say that okay, the program must terminate, but before terminating, it has to free this memory. It has to close certain files. It has to close certain sockets. So the shutdown can be in a safe manner. This is a example of local goto. So in a function we can put some line labels which are the error handlers, and in our code if a error is encountered, we can go to the error handlers which are located inside the function itself. So that is why this is a example of a local goto. This is an example of the global variable method which is provided by the error no library. So here we have a global variable error no which we set to 0, and then we perform a computation. If there is an error, then the library sets the value of this variable to some other code. So these edom and erange classes, these are either constants or they are macro definitions or they are enums. So the library sets error no to these values. So we can check and see whether there is an error or not. Next we have the abnormal termination wall. So we have functions abort, exit and at exit. Then as you know that we have the assert library. So the assertion functions, they are called when the ndebug macro is not defined. So when ndebug means no debug. So when the ndebug is defined, it means that this is a release build. It will be shipped to the users. So the assertion statements are not done. Only while debugging it's done. So suppose like here you can see that here you can see that there is a assert, and inside the assert we have given a condition. So when it's a debug build, this will be checked, and if there is a error, then the error will be reported like this: assertion failed plus plus I equal to 0. Next we have the non-local goto. So this one is the like the most non-intuitive one. So I think it's better to see with an example. This is very similar to the try-catch statements in C++. So first we have to set a global buffer. First we have to set a global buffer which stores the context of the program. Then we use this kind of a syntax. So this is similar to the try block of C++, and this part is similar to the catch block. This part is similar to the catch block. Now we call this function over here, and inside the function if there is no error, then the function is called like this, and if there is no error it returns back here. And wait, I'll explain. So it returns back here, and the else part is not executed. But when there is an error, it goes to this function, and from this point itself it goes to the catch block. It does not execute the rest of the lines. From this point it jumps to this else block which handles the catch clause. Somebody has raised a hand. Somebody had raised a hand, but they seem to have left. So we'll continue. This is an example of the signal.h library. Here we make a signal handler. So this function will be called when a signal is sent to this program by the OS. Then we use this function to register the handler. So here you can see that this constant is called sig abort. So from the name you can guess that when the OS will send the abort signal, this signal handler function will be called. Now obviously there is a default signal handler, but here we are overriding it. So here you can see when we call the abort function, this handler is called and the message is printed. So the C style methods, they are destructor ignorant, so they do not destroy the local objects. So there is a leak of resources or there is a leak of memory unless you carefully program it. And it is obtrusive also, which means that interrogating return value or global value results in code clutter. So as you know that if you use the function type way where the function returns a error code, then every time you use the function you will have to check the error code. Then it's inflexible and it's non-native, which means that the language itself does not support the feature. We have to use we have to work around it. Next module we have error exception handling in C++. So the main difference is this. So it is like the long jump method. Here we include the exception header, and then we use a try catch block. So whatever code is inside the try block, the if it throws a error or if it causes a error, the code will jump to the catch block over here, and then here the exception will be handled. When it jumps to the catch block, it can also pass on a object which contains information about the exception. Okay, so when there is no error from this line, it calls the function, and from the return line, it returns back to the try block. And after the try block, the catch block is skipped, and it goes to return 0. Now, when there is a error, it goes over here, then it encounters this throw line, and from here it jumps to the catch block. It skips the rest of the execution, and over here also it skips the rest of the execution, and it jumps to the catch block. Now the difference is over here all the local objects are destroyed, so stack frame of G unwinds and the destructor of A is called. So this is safer than the C solution. We can also put a series of catch blocks to handle different kinds of errors or different types of errors, and it is also possible not to handle the error completely. Like if the error is thrown at a very deep function call, then what we can do is that Like if at some point it is not possible to handle that error, what we can simply do is we can throw the error again. So then the error will be sent back to the higher level function. Here also you can see that the f function is not handling the error, so it is throwing the error out. Now the advantages are that it works with destructors, it properly destroys the local objects, and the stack is also unbound. It is unobtrusive because the normal flow and the exception flow is kept separate, and it's precise because uh, we can specify lots of, we can granularly, we can, there is granularity in handling the error. We can choose to handle the error at some point, or we can choose to send it higher up in the function. We can choose which kind of error we want to handle. So there is lot of precision, and it's also a native part of the language. It's not some workaround. Here are some other advantages. It can have multiple try blocks. It can have single or group of handlers, and it's fault tolerant. Next, we come to a new kind of feature, which is templates. So templates are actually quite easy. Templates are quite easy. It is used to prevent code repetition for varying kinds of data types. So if you have some general algorithm like max, or if you have some general class like stack or queue, then the types of the data might be different, but the logic is same. So in this case, templates are used to reduce code duplication and repetition. For example, if you want to compare numbers, so we'll have to write a max function for all the different kinds of numbers and all the different kinds of data types. Like if we write one function int max for int x and int y, then this function will not properly compare doubles or floats. So we'll have to write another function for doubles and floats, but the logic in all these functions are same. So in this case, we use function templates to reduce the code repetition, and I'll show you how it's used. So this is the function template format. So first we write template, the template keyword, and then in angular brackets we write class T. So it says that in the following function, uh, T is a data type. So in this following piece of code, T is a data type. Then here we specify the format of the function. So we say that max function, it accepts let me write it in big. This is the function body. So it says that whatever type this is, it's specified over here, it will accept two arguments of that type and it will return another argument of the same type. Then in the actual body of the code, when we are in the actual body of the code, when we are calling the function, we'll have to specify the max function and also the data type. We'll have to specify the max function and also the data type, and then we can call the function normally. So this int data type, it will be substituted over here. The function will create a new function with, I mean, the compiler will create a new function where t is replaced with the actual data type. Similarly, here we are using max and double. So the compiler will create a new function which replaces double in place of t. So after the main code is compiled, there will be two max functions, one for int and one for double. It is exactly the same as what we do manually, but here it's automated. We can also specify a specialization, like we can say that if in the max function a character pointer is passed, then treat it differently, don't treat it in the same way. So this is also possible. Next we come to the class templates. This is exactly same as the function template thing. So in the function templates we create new functions based on type. Here we'll create new classes based on some argument type. So as you can see that here we are creating a stack class, but a stack class, like logically a stack can be used to hold anything. It can be used to hold integers, doubles, strings, some custom types or some big objects. It can be used to hold anything. But when we write code for the stack class, it is necessary to specify a data type. So what happens is that this stack will not be usable with other data types. So we'll have to write different stack classes for different types. To avoid this, what we can do is we can make a templated stack class where instead of specifying this type, the type of the data, we say that take this data type as a template parameter. Then the compiler will create separate classes automatically for whatever types we have used in our code. Like here we, above the class we write template, and in angular brackets we write class t. So this means that in this next piece of code, treat the variable t as a name of a type. So here you can see it's the same, but instead of specifying the uh, type of the content values explicitly, we are using this t. So the advantage is that we don't have to repeat it for different values. It will, like, we can use store different kinds of objects here, and the compiler will generate classes. So how do we use this? When we are writing the when we are initializing the a variable of the stack class, we'll have to specify the exact type that will be there. So here we write char. So what will happen is that char will be replaced in the above definition. So instead of t, everywhere char will be replaced, and the compiler will create a new class. If we write stack and in angular brackets we write int, then in place of t, int will be replaced. So I think this is it for class templates. Next we have functors or function objects. So a functor is anything which allows us to call it. So a callable entity is an object that can be called using the function call syntax. So we can call it like this. So if a object defines this function or this operator, then we call it a function object or a functor. This is the function pointers as you have seen in previous slides. So this is a simple example. This is a normal function which takes two ints and it returns a int. Then we have a class called adder functor, and the adder class, it overloads this operator. Actually not overloads, it defines the, it implements this operator, this angular parenthesis operator, and it does the same thing. So now what we can do is we can use this class as a function. So we define a object of this class and we can call the object like this. Okay. Anybody has any questions on this? Because after this we'll go to the exercises. Okay, then let's go to the exercises. So this is the first exercise. So this program is here, and then what will be the output? What will be the output in two consecutive runs if this statement here, like this line is replaced with this one and this one? So what will be the output? Okay, then let's continue. So first we have a function here which accepts a integer, and if the integer is non-zero, then it throws the integer, and if the integer is zero, then it will throw the string capital, like it will throw the string 0. Then in the main function, so note one thing, that this test it function, it will always throw something. Okay, so this test it function, it there won't be a case where it runs normally. It will always throw some error. Now in the main function body, we have a try statement, and then we have multiple catch blocks to handle different kinds of errors. And as you know that the catch blocks are matched in the order of appearance. So whatever error object is thrown inside the try block, first this catch block will be matched. If this does not match, then the second catch block will be called, then the third one, and then the fourth one. And now this is the catch all block. When we write catch and then three dots, it means that catch all, it will catch all kinds of objects. So in the first case, we are writing test it and 3.14. Now this is a double. This is a double, but function in the function argument, it accepts a integer. So what will happen is that this will be converted into an integer. And now the 3.14 will be converted into the integer 3, and then the condition will be if 3. Now 3 is not 0, so this throw I block will be called. So as you know that if 3, this will evaluate as true. So the throw I block will be called, and since I is a integer, an integer object will be thrown. Now in the order of the catch block, you can see that the integer catch block is the first one. So it will match with this one. It will match with this one. So in the first case, int will be printed. Now we come to the second line. In the second case, we write test it and 0. Now had we written 0.0, then it would be a double, but in this case 0 is a integer, and then again it will go to the function. Again it will go to the function, and now I is equal to 0, so the if part will not be executed. If part will not be executed, the else part will be executed, and here it will throw a string. And as you know that this fixed kinds of strings are represented as const char pointers. In the program anywhere, if we write a fixed string like this, like string literal, then the data type is const char pointer. So in the hierarchy, we will see that it matches with this catch block. So this will be printed, and the output will be int and string. So it will match with this one. So anybody has any questions on this? Okay, then let us continue. So this is the second question. Okay, let us continue. So first here we are defining three exception classes. So when we write throw and then we write something here, we can throw any kind of object. We can like normally something of the except std exception, normally a derived class of std exception is thrown, but it is also allowed to throw any kind of object. So here we are creating three classes which are our own classes. So they are not derived classes of the exception class. uh, so now in the first class we are defining a virtual const characters pointer what function. So the function name is what, and it's a const function, it does not modify the object, and the throw keyword guarantees that this function itself won't throw exception. So this function will run error free, that is the guarantee, and it returns this string. Next we have db error class which inherits we have db error class which inherits from the internal error class, and it has the same function signature except it returns db exception. And in the last one it again derives from the db error class, and it returns sql exception. Now in the main class, in the main function, within try blocks we are throwing a sql error object, and then we have multiple catch clauses, and in all the catch clauses we are printing e dot what. So we want to know what is the object, what is the exception that was has happened. So now what will be the output? So in this case, SQL error is thrown, but note the class hierarchy. So first we have internal error, then we have DB error, then we have SQL error, and as you know, in the catch blocks, upcasting is allowed. So the actual object that is thrown is a SQL error, but an SQL error is a derived class of internal error. So it will match with the first catch clause. Okay, it will match with the first catch clause, and this statement will be executed. So the e dot what function will be called. But here this is the trick. So note that what is a virtual function. So the what function that is actually called will depend on the runtime type of the object. Now the runtime type of E is SQL error. So this function will be called. This function will be called, and SQL exception will be printed. So the answer is B. So anybody has questions on this? Okay, now let's continue. So again here there are some classes and we are throwing exceptions, and what will be the output? Now this should be easier because here there are no virtual functions. Okay, let's continue. So here we are first defining a namespace, and in the namespace we have three classes, three error classes which derive from each other. So first we have internal error. I'm just writing internal. Then we have DB error. So this derives from internal. And then we also have SQL error. So this is the class hierarchy of the exceptions. Now we have a global function called proc, where we in the try block we are throwing a SQL error object. So first we are giving the namespace name, which is server exceptions, and with double colon we give SQL error, and then we have implemented a catch block. Now note that the catch block itself throws another error. So this will be handled by some upper level function. Now in the main code, inside a try block, we are writing proc. So we are executing this function, and then again we have multiple catch blocks where we are catching errors of various types: internal error, SQL error, DB error, and at the last we have a catch-all block. So what will be the output? So first we go to the main function. Then in the try block, it's calling proc. Now coming to the proc function, it also has a try block which throws a server exceptions SQL error, and then in the catch block also we have server exceptions SQL error. So this object will be caught by this block. So this object will be caught by the server catch block. Now the catch block itself throws a DB error. So now this function is finished. Over here over here now the proc function, it is throwing a DB error. It is throwing a DB error. Now as you can see, there are no virtual functions here, and we know that we can upcast also. So DB error is also an internal error. So the first first catch block will be caught. First catch block will be matched, and the sentence internal error will be printed. So the output is in this case is A. Okay, anybody has any questions on this? Okay, then let us continue. This is the next question. Okay, now in this function, we in this piece of code we have a function throw it, which throws a string called divide by 0, and there is a catch handler which accepts a integer reference and it throws it. So there is no handler for string types. Now in the main body of the code we are calling throw it. Then we have multiple catch handlers. Now note here that the catch handlers are matched in the order of appearance, so they will be matched in a top down fashion. Now here it logically there is a error because the catch all block is placed in the top, so this will catch, like logically this will catch all the exception types, so the second and the third catch blocks, they won't be executed, they will never be matched. So this is a logical error. So the compiler will throw error, it will say that the catch block must be at the end, catch block must be at the end. So in this case the answer is D, compiler error, dot dot dot, handler must be the last handler, something like that it will print. Now if we had actually put catch at the last, then as you know, like this throw it function, this throws a const cat star type exception, okay, because it throws a string. So this won't match with this one, it won't match with this one. So in case the catch-all block was at the last, it would match with the catch-all block and default would be printed. Default would be printed. But right now, like the actual answer is this one. So any questions on this? Okay, now let's continue. Okay, so the answer is D. Compiler error, handler must be the last handler. But what I was saying is that in case the catch block was the last one, then in that case default would be the answer. This is the next question. Please try on your own. Okay, in this question, so Anubha is correct. So Anubha is correct. The answer is C. So basically over here, like it is confusing to read this side of the this part of the code. So I would say look at the main function. So here we have a class called modifier, which is a templated class, means that it accepts a type and then we initialize it with something, and it implements one function called subtract, which takes an integer. So in the first line, d dot subtract 4, it is quite intuitive to understand that what will happen. So 26.4 is given, so that will be subtracted. Okay, so wait a minute. uh, that will be subtracted from this value, so 22.44 will be printed. And in the second line we have s dot subtract 4. Now in this case s is a string, so how do we subtract an integer from a string? There is no proper way, it has to be defined according to the use case. So on the left actually, there is a general definition of this class and there is a specific definition. So as you can see in the generic definition, it has one type parameter called t, and then we write the class name. It has a data member t val, so the val data member is of type t. Then there is a constructor which sets val equal to underscore val over here, and now it implements the subtract method, which basically just subtracts the value from the data member itself, and it returns the resulting value. Now we come to, so this is the general class. So whichever, actually see, to perform this subtraction we need the minus operator. So whatever classes implement the minus operator, they will work with this general function, general class. But if there is any object which does not override the minus operator, in that case we'll have to write a specific one. So in case of strings, here we have written a specific one. So what we do here is first there is a constructor which copies the value of underscore val to val. So there is a copy using strdup, and now we implement the subtract method. Again it takes an integer and a char start. It allocates memory for the returning string. It allocates memory for it, and then it copies all the characters except the last d characters. So this is the meaning of the subtract word in this application. So if we have a program, uh, like in this case the string is programming. In this case the string is programming. So what we mean here by subtract is that we'll subtract the last d characters. So these, in this case d is 4, so d equal to 4. So these characters will be erased and the output will be just program. So that is what this function is doing. So now the main question is that how do we tell the compiler that this is a specific case for the more general class. So we use this kind of syntax. Here we write template and then empty angular brackets, and here we write the exact value of the type. Here we write const const char pointer, const char star. So now you might ask that why do we have to write the empty angular brackets? So this is because your templated class or templated function, your templated class or templated function might have multiple arguments of class. You can have something like this. You can have template class T, and then you can also have class T2, and inside the function you can do something. So in case your templated function had multiple arguments, uh, and you are overriding only one of them, here you would specify the other argument. So that is the logic behind this one. Any questions on this one? Yes, Anubhav. Okay, okay. So a templated function or class can have multiple template arguments. Like you can have a function like this, template class T, and you can also have class T2. Okay, and then let us say we have a function called ret first. So we can have a templated function like this, which has two template, which has two types, so two template parameters, and in the function body also we are using the two parameters. So the first argument is of type T, second argument is of type T2, and this function it returns. Okay, so in this case the mistake, this one will be X. We are returning the first argument. Since the type of the first argument is T, the return type is also T. Now it might be the situation that we are writing a specialized class, but where the first argument is an integer. So over there in the template list, the second one will still be there. So so it might be the case that we write a specialized class like this, where we are overriding only the first one, first argument. So in that case, in the parameter list, there will be T2 also. So that is why the it is necessary to write the template thing above the function line, even when we are specializing. Any questions? This is the next question. Please try it out. Okay, so in this question we have a templated class. We have a templated class called multiprint that takes a type name t and an integer n. So in templates we can specify types and we can also specify an integer. So that is the only two things that are allowed. One is a type and the other one is an integer. So now in the class we have a data member. We have a data member t val. We have a constructor that copies underscore val to val, and we have a function called output that prints val n number of times. So if n is 2, it will print t 2 times. If n is 3, it will print it 3 times, like that. Now in the main body of the code, we are instantiating a class with first argument as string and second argument as n, which is 3. And then we are constructing it with the argument hello. and then we are calling d dot output. So logically this is supposed to print hello 3 times, because this hello will be copied to val, and n is 3, so hello 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 will be printed. The only slight problem here is that when we have integers in the template argument, they must be constants. So here n is supposed to be a constant. Since n is not a constant, it will throw a error. It will throw error. So the answer will be D. So the answer is actually D. The compiler will throw an error at line 2, which says that non-type argument must be constant. So here n should be constant. Now let's say that n was constant. Let's say that this was the line instead, where we have const int n equal to 3. Then in this case the output will be B. Okay. Any questions on this one? Okay, then let's continue. This is the seventh question. So this one is quite easy. Please try on your own. Okay, in this question, in this question we have a templated function called print where there are two arguments x and y which are both of type t, and then we are printing both of them. So now note one thing, that here we are not explicitly specifying the type. So in any templated function or class, ideally we are supposed to specify the type. So let's say we are supposed to write print and in angular brackets integer, and then in the arguments we can specify two integers like 20, 30. So this is explicit. But we can also do it implicitly, where we just write print 20, 30, and the compiler will try to guess what is the type. So this guess must be unambiguous. If there is ambiguity, then the compiler will throw an error. So over here, so this is multi select. So in the first case, first argument is integer, second argument is character. So, and as you can see over here, both the arguments should be same. So it is not possible to derive the type. So the first one will throw an error, compiler error. Now coming to the second one, here both the arguments are integers. So the compiler can guess that the template argument is probably an integer only. So second one will compile fine. Now we come to part C. In part C, the first argument is double, second argument is integer. Again, there is ambiguity and the compiler will be confused about what is the correct template argument. So this will throw an error. And in the last one, second argument is an integer. First argument, we are typecasting a character to an integer. So the first argument will also turn out to be an integer. So this will not throw an error because the compiler can deduce that the template argument must be an integer. So this one is also correct. So in this question, the compiler will throw errors on A and C. So that is the answer. So anybody has questions on this one? Okay, then let us continue. This is the next question. Please try on your own. Okay, here in this question actually there is nothing much to understand. So it is just, if you know it you can do, if you don't know it you can't do. So Anubha is correct here. The answer is D. So let us proceed now. Please try the question. Yes, again, Anubha is correct in this question. The answer is B. So this question is about functors or function objects. So functors or function objects are anything that override the call operator. So they can be called as functions. I mean, they can be used as functions. So here we have a struct called division. So struct can be used as a class also. In the difference is that in class everything is by default private, whereas in struct everything is by default public. So here we have a struct which has a data member R, and then we are defining a constructor that copies underscore R to R, and then here we have to define a function. So what this function does is that it divides, okay, it performs division and it stores the remainder in R. Now we come to the main function body. So in the main function we have a equal to 35, b equal to 3. We are initializing a division class. I mean, we are initializing a division object with 0 as remainder. Now we are dividing. So div ab in d equal to div ab. And then we are printing d and div dot r. Now note here that div is actually an object, and here we are calling the object. So this might a bit strange. Okay, this might feel a bit strange, but we are div is an object and we are calling the object. So this is supported when we override the parenthesis operator. This is mainly used so that if there is any function that has some kind of state, which has to be stored, then it can be stored using this method. So out of the options you can see that only B and C, they overload the parenthesis operator. So this one, it does not overload. First one just defines a normal function called operator. It does not do operator overloading. So in B and C, operator overloading is done and parenthesis is overloaded. But in C, the return type is void. Whereas from the main function, we can see that the return type is supposed to be integer. So the correct answer here will be B, which is we are overloading the parenthesis operator. It returns the integer and it takes two integers here. So we will replace it over here. We replace it over here. Uh, so after doing this division will be performed and quotient and remainder will be there, which can be printed. So anybody has any questions on this question? Okay, then so we move to the last question for today's session. So this is the last question. This is similar to one of the questions you did previously. Yes, Toshika, so D is correct, but there is another option also. D is one of the correct options. Yes, C and D. Okay, so as you can see again, we have a function called templated function called compare, which takes two arguments n1 and n2 of the same type t, and it returns n1 minus n2. So again, So this is, since this is a templated function, we are supposed to specify the type such as int or double. So we are supposed to specify the type. This is the explicit way. However, we can also do it implicitly, where we just write compare and don't specify the type. So this will only work if the compiler can figure out what is the type. So here both of the arguments have to be same. So here both are char. So this one will work correctly. Here both are double. So this one will also work correctly. Here one is double, one is integer. So here it will fail. Here also one is character and one is integer. So here also it will fail. So the compiler will generate errors in case of C and D because of the type mismatch. In A and B it will work correctly. Okay, so any questions on this one? Okay then, so thank you for attending today's session. So I am concluding the session now. So that's all for today.